random. So data does not, so here data does not affect dependent variable, independent variable, and there is missing out at random. So this type of data is missing and it affects independent or dependent variable. So for an example, if we are examining effect of family income on academic achievement, but we do not have data on family income. So while working on SPSS, if we need to find out, so like working on SPSS, what we can do is we go to discrete data. There we can enter like 99, and then that table comes, the output comes where it shows that okay, so for like we get data like 99, so for 99 we get two values. This means that two data responses are missing. Then also we talked about the outliers. So we get the box plot, and like for example, the respondent who hasn't answered that particular question, so it get reflects. So his or her respondent number comes there. So for example, like a 22nd respondent hasn't answered any particular question that we are looking, or his or her value is missing. So in outlier, it will represent, like it will get denoted there ki 22 will come. So we will come to know that 22 respondent hasn't, like the subject number 22 hasn't given response to the particular question. Hello, am I audible? Sir, am I audible?
Yeah, you are audible.
Okay, thank you.
Hello. Hello, Shaptapurni. Yes, sir.
So please you tell about the central tendency. What is the meaning of the descriptive statistics and why do we use the descriptive statistics? What is the purpose of descriptive statistics?
So, sir, central tendency is the central value for any probability distribution, and it is important if we want to calculate the average of any data,
Yeah.
or we want to know the center point of a data.
Okay. When we are talking about the central tendency, so what are the statistical tools are within the central tendency?
The mean median
Sir,
mode.
mean median mode.
Mean median mode. Okay.
Yes, sir.
So what is the difference between mean and median?
The mean is average and median is the middle value.
Middle value. So when we can use the median and when we can use the mean? Hello, Mona Lisa, are you here? Okay. So when we are using median and when we are using mean?
So when we have to calculate average, we compute mean, and median also for skewed distribution.
Yes,
We
but
calculate.
when we are using the median,
So to measure central tendency for skewed distribution,
when the data is robust. Okay. What is the meaning of the robust statistics? That is when the data does not follow the normal distribution. Is it clear or any question? So when we find the robust statistics, can anybody tell me? When the data does not follow the normal distribution, so how we can tell that this data does not follow the normal distribution?
so if data is skewed,
When the data,
is skewed,
correct, when the data is skewed in nature. Very good. When the data is skewed in nature. So when the data is skewed, then we can use only the median, not the mean. Is it clear?
yes, sir.
Can anybody tell me when mean, median, and mode, these three will be 0? The mean, median, mode, the values will be 0.
So normal probability curve.
Correct. So when the distribution follows the normal distribution, then we can find that is the mean, median, and mode is 0. Okay. Saptapurni, can you tell the types of skewness? Hello, Sapto. No. What are the types of skewness, Ashita?
So kurtosis,
Hmm? Skewness.
So positive skew, negative skew.
Correct. So two
Sir,
types of
right, left,
skewness
and
we
zero
find.
skew.
Huh?
Sir, right and left skew.
Right and left. Usually it is called the positive and the negative. Huh? Positive skew and
Okay,
the
sir.
negative skew instead of the right left. Right left for your understanding it is fine, but generally it is called the positive and the negative skew. Okay. So when the distribution is skewed, then what we can do? We can use only the median. Okay. Is there any question? No. In the normal distribution, we find that is mean, median, and mode is 0. Why mean, median, mode is 0?
So
Can
because
anybody
it
tell me?
denotes central data, which can be used
Because,
to
yes,
represent
so
all.
50-50 total distribution is equally divided. Therefore, the middle one, that is the mean, median, and mode, that is 0, since it is distributed. Okay. Like skewness, there is another concept, that is the Kartosis. Any idea about the Kartosis?
So it is measure of combined weight of distributions there.
Correct. Correct, correct. Okay, now I am showing you one is this data visible?
No, sir.
No. Is it visible?
No, sir.
This data visible?
Yes, sir.
Okay, now what I can do, so this is the age data. Okay, 10 people are there and this is their age. So what I am doing, I am going to the analyze and then descriptive statistics. There is one frequencies. Okay, I click it. Then I click age. I click chart. Okay. Then I click the histogram and then show normal curve. Is it visible to all of you?
Yes, sir.
Now let's see what is the distribution. Again, I go to the place, analyze, descriptive statistics, frequency, age is there. I press OK. Nothing has come. Now is it visible?
No, sir. Yes, sir, it is visible.
Okay, so here you will find that is 23. Okay, frequency is 3. That means 3 people, their age is 23. Okay, likewise you will find that is the percent and valid percent and the cumulative percent. Cumulative means addition. So 30% plus 50% plus 60%, like that you will get the 100. And this is the distribution where you can find that is the 3 people, their age is 23. 2 people, their age is 25. Another 2 people, their age is 30. This is clear now? Now I am coming to the histogram. Hello, is it clear?
Yes, sir.
Yes, sir.
So whether this data is skewed or not.
It is positively skewed, sir.
Yeah, this is positively skewed. Correct. This is positively skewed. Now you will find that mean is 28.7. So mean falls between 25 and 30. So mean is at this point. Okay. Mean is here, maybe. That is the 28.7. And the standard deviation is very high, 6.84. Okay. Now we can go to, we can check options is there. So we can check the Kartosis Skewness, and then continue. Then okay. So you will find the skewness is 1.655 and Kartosis is 3.095. That means the distribution is robust in nature. Is it clear now? So when your distribution is robust, then it is better not to use any statistics or statistical tool mainly related with the parametric assumptions. Okay. So the statistical tools, the parametric statistical tools, they are following the assumption of normal distribution. So when your data is robust in nature, it is better not to use the tomar parametric statistical tool. So can anybody tell me about the some parametric statistical tool?
The correlation, regression.
Correlation, regression, correct. Correlation, regression, heat
ANOVA.
statistics, right? So these are the parametric statistical tool. So it is better not to use any parametric statistical tool. Now again, I am going to analyze descriptive statistics. The frequencies are there. I can click the statistics, mean, median, mode. Okay, these three are there. Skewness, Kartosis. Then click, then okay. Now you will find that is the mode is 23. Can anybody tell me why mode is 23?
So because respondents are of maximum 23 years old.
So it's a common number.
Yes, because the frequency is 3. I know. Frequency is maximum. Therefore, the mode is 23. And again, you will find the mean is 28.7 and the median is 27. Okay, so mean and median, they are close, but they are not same. That means some discrepancy is there. Okay. Skewness also 1.655, standard of 6 skewness 0.687. But you know that is the standard of Kartosis is very high, 1.334. So when you deal with the descriptive statistics, okay, it is always better to check the mean, median, mode, skewness, Kartosis, and their standard error, all of them for describing the data. Is it clear to all of you?
Sir, I have a question.
Sure.
So what should be the appropriate value of skewness or standard error of kurtosis in order to move further with our analysis?
Yeah, the more it will be close to the 0, then that will be better.
But sir, here 1.3, it is close to 0 or
This is the standard error of Kartosis. That means it is very high, more than 1.
okay.
Okay, now another interesting point is, so I am thinking that is 10 individuals are there, okay, and the mean is 28.7, clear. Then I can go to the graphs, then legacy dialog, then I can click the box plot, then simple. Okay, not possible. Please tell me whether it is visible or not. I think this is visible. Yeah. So I'm doing the box whisker plot, simple. The summaries of separate variables, I click it here. Then define. Then I click age here. Okay. And then okay. So this is the box whisker plot. Hello. Is it clear?
Yes, sir.
But can you tell me that is why there is no line below the Q1?
So because data is skewed.
Because there is no, that is the Q1 and the minimum value, that is same. Okay. The Q1 and the minimum value, that is same. Therefore, we do not find any other whisker towards the minimum direction. But in case of the maximum direction, we find one outlier, and this outlier is 3. Okay. Is it clear? Hello.
Yes, sir.
So what I can do? I have understood there is one score, and that is 45, the third row. So if I go to the data, original data, so I find, now if I go to the original data, I find that is the third row, 45 is there. Okay. So now I want to consider it as a missing data. Then what will be the solution? Hello. Yesterday I have told you.
So we have to find out the average.
No, I want to consider this 45 as the missing data. Then I can click here. Okay.
So we will assign 45 value of 99 or any other value.
So if I write 45 as the missing data, and then if we analyze and if I calculate again, that is the graphs, legacy dialog, box plot, simple. Is it clear now? So
Yes.
it considers the data, 9 data. So there is no outlier. And the box size is better, high. So if there is any outlier, then what will happen? The box size will be small. If outlier is less, then box size will be bigger. So that is the beauty of the box whisker plot. Is it clear?
Yes, sir.
So box whisker plot is very powerful tool. Now again I am going to the original data. So I don't want to any missing data. Okay. Then what I can do? What is the average of this distribution? 28, right? 28 is the average. Then what I can do? I again go to the variable and then missing data. Then I say no missing values. Okay. After that, I go to the graphs, legacy dialog, box plot, simple. Okay. Then I get, you see, then I get the 10 data. Okay. Is it clear? Is it visible? No. Please you tell me, huh? Because I'm changing output. So now you can find out that is that 10 individuals are there. So what I have done, I change the value. Okay. In case of the third row, I change the value. I have written it is 28. Why 28? Because the average age is 28. Therefore, I have written 28. Then what happens? Then there is no missing value. So if you go to the variable view, you will find the missing is none. Is it clear?
Yes, sir.
Now, if I want to know something more, for example, I don't want to use more than 23. Sorry, more than 25. Then what I can do, I can go to the variable view, then none, then it click, then range, low, high, 25. Low is 25 and this one is 30. Then okay. Then I again analyze descriptive statistics, frequencies. What I get, so 25, 28, 29, 30, all of them are considered as the missing value. Is it clear? So the valid data is only 4 and missing data is 6. Hello.
Yes, sir, understood.
This is clear now.
Yes, sir.
So what I have done, I have considered from 25 to 30, these individuals, they will not be in the analysis. Okay. Therefore, the valid data is 4. Is it clear?
Yes, sir.
And you will find the missing value is 6. Is it clear or any question? So we can handle the missing value in this manner also. Okay. So today we have understood the descriptive statistics. The distribution of the data. Now I am writing here please you follow me. I am writing here some data arbitrary. Is it clear now? So
Yes,
if I go to the graphs, then again legacy dialog, then box plot, then simple. Okay. Then if I click it, okay. What we get? Very small. Huh?
Sir, screen is stuck.
The box size is very small. Can anybody tell me why the box size is very small?
Because outlier is present.
Correct, due to the outlier. So if outlier is there, then your data will be seriously affected. So we have to remove the outlier. We can consider this particular value that is above 32.5, right? Above 32.5 যদি কিছু থাকে, if it is there, then it will be considered as the missing value. So if I go the variable view, if I go to the variable view and we put the missing value, then what happened? Sorry, 32, 35. Then again, if I go to the graphs, okay, then legacy dialog, then box plot, then simple, then define, then okay. এটা কি হলো? Oh, two data are there. So we have to remove this particular data. Okay. How can we remove this data? We can go to the data view. Okay, so it is written 34. So if I change it as 28, and then if we do the graphs, then again legacy dialog, then the box plot, simple, define, okay. Okay, so now the box is big. Now the box is big because there is no outlier. I think this is clear to all of you.
Yes, sir.
Yes.
So if you have any data, you can check. Okay, because outlier seriously affect your data. specifically when you are using correlation statistics, you must be very much clear about the outlier. If there is any outlier, then your correlation coefficient will be seriously affected.
So can you please repeat it again?
When you are using correlation statistics, you first check the presence of outlier. In SlideShare, you will find my research. That is the income and expenditure of agricultural farmers. So initially, I find there is no significant correlation between the income and the expenditure of agricultural farmers. Then I'm very much worried. How is it possible? Have I missed some of the expenditure? Then I am thinking that is, okay, what is the data? I have observed that one farmer was there and his income is very high. So high when I considered that particular data as the missing data, then I find the correlation is very high. So the income and expenditure correlation high. So why does it happen? Because I have removed the outlier. Is it clear to all of you?
Yes, sir.
Yes, sir.
Okay. So please you write whatever you have understood today in the group. Okay. That
Sure,
will
sir.
justify,
Okay, sir.
that is because you will get the certificate. Na? Dr. Ramamanna, she will get you the certificate. And she will give you the certificate. So we must be very much aware that is whether you have understood it or not. Okay.
Yes, sir.
So please close your hands. Om Purnamada Purnamidam Purna Purnamudachyate Purnasya Purnamadaya Purnameva Vashishyate. Om Shanti Shanti Shanti. So tomorrow again we will sit together by the same link. Okay.
Sir, one doubt, sir.
Yes, Rajiv.
Sir, actually, I didn't know the routine of this class, so that's why I was just watching. Sir, you told that if the distribution is skewed, data is robust, right?
If the distribution is skewed, data will be robust, right?
Robust, and actually
That
the
means
meaning.
the data is not the normal.
Okay, that data is robust means that data is not normal. Okay, okay. And sir, whatever is being taught, we are supposed to write in the group, is it?
Yeah, whatever you have learned today, you will write in the group.
Okay. type in the group, type or write and take the photo? How's it like?
Not the photo.
Oh, okay.
Not
Okay.
interested with photo.
No, I mean, sir, write in the paper and
That is for the child. This is not our target. We are providing all sorts of energy to educate you. Okay,
sir,
so
I didn't
photo,
mean that,
what's
sir.
the purpose of photo? Photo is not
No, sir,
very good.
what I meant is write in the paper and take the photo of that and post it, or just type whatever we have
No,
learned
just
there.
you type,
Okay.
whatever you have
Okay.
learned today
Okay.
in the group, okay?
Okay.
So that
Okay, sir.
people will interact much more.
Right.
Okay. Thank you.
Thank you, sir.